All right, guys.
Yeah.
Let's go ahead and get started. I'm going to leave it up in this kind of mode here for now, I guess. So, a couple things here. Our panelists are John Kim, Director of Storage Marketing from Mellanox; Tom Spencer, Senior Director of Product Marketing from SolarFlare; Ron Hendricks, Senior Product Line Manager from Broadcom; Praveen Mehta, Director of Marketing Server Connectivity from Marvell; and I'm Mike Human, Managing Partner at G2M Research. Our webinar, as you can kind of figure out today, is on NVMe over Fabric. Let's talk a little bit first about what NVMe over Fabric is and kind of why it exists. So NVMe over Fabric extends the NVMe flash-based block storage transport protocol to fabrics that are used in the data center. NVMe was originally put together for PCI Express. The reason it's important is that it eliminates a lot of the protocol overhead that was inherent in the previous SCSI protocols. Think here of things like iSCSI or Fiber Channel Protocol, which were really built around rotating media. NVMe got rid of all that, and NVMe takes that same concept and extends it to fabrics. As most of you probably know, NVMe over Fabric is a standard. It's managed by NVMe.org, the same group that put together the NVMe standard. And here you can kind of see on the right some of the improvements in performance that we've gotten by going to NVMe over Fabric versus using NVMe or versus using SAS and SATA, which were both based upon the SCSI protocol. So a couple definitions here. I've seen a lot of different definitions, a lot of different acronyms. So let me kind of go through these real quick. So there's 3 NVMe transports that run over Ethernet today, or there will be 3 very shortly. The first one, NVMe over RDMA over Converged Ethernet, or NVMe over RoCE. NVMe over iWarp is another one, and the third one, which should be ratified very shortly by NVMe.org, is NVMe over TCP. On the fiber channel side, NVMe will run over fiber channel. That's called NVMe OFC, and it also is available to run over InfiniBand, which is NVMe over IB. With that, let me give it to John Kim. John, go ahead and take it away.
Thank you very much, Mike. And for all those in the United States, happy Election Day. So let me go ahead and get started here. So Mike, is it possible to, this slide has builds, is it possible to back up? I don't know if it's possible to unbuild it or if it's, they're just fixed. Let's see. Yeah, if we can put it in presentation mode and.
1 second, because it's probably going to try to show up on a different screen, actually.
Actually, that was looking, I thought that was looking good to me, but that was your presentation screen, I guess. But.
Yeah, let me, hold on 1 second here, sorry. There we go. All right, John, go ahead.
All right, let's move to the, oh, that looks good, thank you. So I want to talk briefly about what Mellanox does. As you mentioned, Mike, this is a very exciting space. There's a lot of progress. There are different transports and different physical networks that can be used. So Mellanox focuses on supporting Ethernet and InfiniBand. And we believe we are the leader, current leader, in terms of NVMe over Fabric's networking cards, in terms of the adapters, whether it's Ethernet or InfiniBand. This is a partial list of our customers who are using us for NVMe over Fabrics, at least the ones we can talk about. So all these vendors here are, some of them are OEMing our adapters, some of them don't sell the hardware, don't sell the networking hardware, but they qualify our adapters, and it's put together by third parties or resellers. And some of them are software-only storage vendors who support NVMe over Fabrics, and they're integrating. So Mellanox is working with all these vendors. Some of them are using only Mellanox, some of them are supporting other vendors as well, including some other vendors on this webcast. So they have a multi-vendor strategy in terms of networking. If you could go forward, do the next build on this slide. But Mellanox, we believe we were out there pretty much first in the world of NVMe over Fabrics for Ethernet and InfiniBand. And we've gotten some awards for it over at Flash Memory Summit. I'm sorry, with IT Brand Pulse. This is an award announced at Flash Memory Summit. We were announced as the brand leader for NVMe over Fabric's networking adapters. So they had many categories, but the networking adapters, Mellanox took it across the board. Okay, move forward. Next build. And we also work with a partner called Accelero. They are a software-defined storage vendor, a pioneer in NVMe over Fabrics, their storage startup, and they had a solution using Mellanox networking that won the Best in Show award. So if we go forward to the next slide, let me talk a little bit about what we've done in terms of innovation. You know, obviously, any vendor who supports RoCE, InfiniBand, iWarp, Fiber Channel, and soon TCP can support NVMe over Fabrics. But what we have done is not only have we been supporting it, but we've been adding different offloads and performance enhancements to our networking so you can do NVMe over Fabrics with faster performance or lower CPU utilization or generally higher efficiency. So we started out with one of our older adapters, ConnectX-3, has supported NVMe over Fabrics, and we have a few vendors who are still using that, but most of them have now moved to our ConnectX-4 or ConnectX-5 adapters, and I'll talk a little bit in a second about what ConnectX-5 and Bluefield do. And then we've also announced, and we'll soon be shipping the ConnectX-6, which is an adapter that does 200 gigabits per second. I think it's the first adapter that'll do that with both Ethernet and InfiniBand, and it will support NVMe over Fabrics over, again, InfiniBand, RoCE, and TCP/IP. So these are the adapters going from the 10 and 40 gig to the 100 gig, and then in the near future, the 200 gig adapter. The Bluefield is a system on chip, SoC, and it can be used as a SmartNIC or as a storage controller. So I'll talk a little bit more about that in a minute. Just a note here that the ConnectX-5 is the first adapter out there which has an NVMe over Fabrics hardware offload on the adapter. I'm not sure if it's still the only one, you know, certainly, but I believe it was the first one on the market and it has some interesting benefits, which if we go to the next slide, it shows that this is the, oh, sorry, if you could go back. Right. So this is actually just a little illustration of how NVMe works over TCP. So as you mentioned, Mike, that standard's not finalized yet, but I understand it's going to be finalized pretty soon. And there's certainly some demand for it. There are people out there who are saying, hey, I want to do NVMe over Fabrics, but I don't want to make any network changes at all. You know, and I'm willing to take a little bit lower performance in return for not having to change in my network. So they'll be able to use NVMe over TCP. And all of the Mellanox adapters will, of course, support NVMe over TCP as well. And we expect they'll do it with pretty good performance. Next slide. All right, so I said that we did some innovation and some offload. Let me talk a little bit about that as I wrap up my section. What is this offload and why does it matter? So this is an example of a typical NVMe over Fabrics with a standard adapter. For example, our ConnectX-3 or ConnectX-4, or other adapters out there from some of our other presenters. And you see that you can do NVMe over Fabrics and you can get some good performance, but the CPU, typically an x86, has to be involved in every transaction, and it has to do some of the protocol management between NVMe and the network protocol. Again, whether that's whatever that network protocol is, the CPU is involved. So this is a test with the Mellanox adapters without offload, and we got pretty good performance, but you can see that half of the CPU was busy dealing with this NVMe over Fabrics protocol. And you had a 15 microseconds of network latency. That's 15 microseconds on top of whatever the SSD needed to do reads or writes. So that looks pretty good, but if we go to the next build, we see that now with the offload, this is the same, this is actually the same adapter, but embedded, the ConnectX-5 embedded inside the Bluefield, and which also has a built-in PCI switch and some other goodies. So now we see that we're getting more IOPS, 8 million instead of 6 million. We're getting, at 4K, we're getting 5 million instead of 2 million, so it's a big change at 4K. But the CPU utilization of the x86 went down to almost 0. And that's because all of the, not only all of the networking protocol, but all of the NVMe protocol is offloaded into the silicon on this Bluefield chip. It's actually in the ConnectX-5 of the Bluefield. So this offload is available also in the ConnectX-5 adapter and the ConnectX-6 adapter from Mellanox. So you can see that the network latency also was cut by 1/3. So again, that's not total latency, but that's the latency on top of, the SSD latency. So if you compare the local to network, before with the regular ConnectX-5 no offload, the networking was adding 15 microseconds of latency. But now with the Bluefield and the embedded ConnectX-5 and the offload, it's adding only 5 microseconds of latency. So that's a big improvement in terms of making the networking more efficient by using this NVMe over Fabrics offload. Next slide. So to wrap up the Mellanox section here, so Mellanox is a leader in NVMe over Fabrics technology, specifically the networking, adapters and switches with Ethernet and InfiniBand. We have several customers that we can talk, actually many customers in production, several of which we can talk about and were mentioned on that slide. And we have others who are designing in our products and will be announcing or doing engineering samples or POCs of NVMe over Fabrics with Mellanox networking in the near future. So we've supported it from the beginning over Rocky and InfiniBand, and we'll soon add support. Actually, we already have support, but when the standard is done, we'll support it over TCP as well. And we also continue our innovation in terms of both on the adapter and the switch, in terms of doing more and better offloads to decrease latency, reduce CPU utilization, and make your NVMe over Fabrics solution more efficient. So that's the end of my section, and Mike, I'd like to turn it back over to you.
Thank you much, John. Okay, let's go now to, it's not Elliot, it's Laurent, is a kind of late substitution. Laurent, go ahead and take it over.
Yes, hi, good morning, everyone. Yeah, so, and this mic, this probably echoes a little bit your introduction, but just to show where NVMe over Fabrics fits in among other storage technologies. So basically, NVMe allows you to combine both scalability and performance. It allows you to combine the performance of NVMe storage and use that with the scalability of technologies such as iSCSI. Right, and those characteristics, scalability, performance, and also the cost efficiency that come with using ubiquitous Ethernet infrastructure that exists in basically every data center. So those three characteristics are what is driving the adoption of NVMe over Fabrics today. Next slide. Right, so for adoption to happen, a few pieces of the puzzle have to come together, and I think we're going to be talking about adoption later today in this session. So basically between 2016 and 18 is when those pieces of the puzzle come together, and I would say that by now in 2018 that puzzle has come together, and we're starting to see the ramp in adoption. Right, so those pieces are obviously the silicon. There are mature and silicon solutions today in production. Those semiconductor solutions have to be used and adopted by the hardware ecosystem. And we're at the point today where you can procure OEM and ODM boxes supporting NVMe over Fabrics from places like Taiwan or China, and PCIe adapters, PCIe form factor adapters that support Fabrics. On those hardware solutions, obviously you need to run software, and there again, we're seeing that the software ecosystem, Linux has embraced Fabrics, and there are multiple distributions today that support open source Fabrics. Right, and then finally, for adoption to happen, you need early adopters that will drive this technology forward and adopt it at scale. And we're also seeing that happening, in 2018. Right, so practically, we're expecting to see large-scale deployments in 2019, and shortly thereafter in 2020, we think NVMe over Fabrics will become the technology of choice for storage over Ethernet. Right, so to take a closer look at where NVMe over Fabrics is relevant. So here are a few examples, or the typical architectures where we're seeing adoption. So on the left side, you have the typical enterprise architectures, and on the right side, cloud or hyperscale architectures. So starting with enterprise, in the classic scale-out type system, you could use Fabrics both on the front side fabric and on the back side. And then same thing goes for the traditional SAN system. You could use Fabrics on the front side fabric. Practically, what we're seeing in enterprise is adoption starting on the back end because it's easier to deploy there. The technology, we believe, is ready today for adoption on the front side, but that's probably going to happen, after it's adopted on the back end. And then, so moving to the right here, NVMe is already being deployed by cloud and cloud vendors and hyperscalers. It started with solutions like you see on the top right quadrant here, with storage servers containing, say, anywhere from 6 to 12, with even 20 disks each, connected using Rocky or TCP. And over time, that solution, that architecture will probably migrate to a more of a disaggregated system where the compute and the storage blocks or boxes will be physically separate, and the two will be connected again using fabrics. Okay, next slide. Right, and so this is my last slide, just to talk a little bit about the Broadcom solutions. So we offer both what we call classic or standard network adapters, performance mix that support RDMA and TCP and whatever other protocols you need. And in terms of SoCs, we have an SoC called Stingray that practically and conveniently can be used both on the target side of a storage system to terminate the NVMe connection close to the media. And it turns out that that same SoC, it's an ARM SoC, can also be used as a smart NIC on the initiator side of a storage system. And as we're going to see, I think, in the discussion, that has using smart NIC in NVMe systems has a lot of advantages. It allows you to upload either the software-defined agent on the smart NIC and relieve the host CPU from that load. It improves security, frees up cores on the host, etc. So I think this concludes my section.
Perfect. Tom, from SolarFlare, your turn next. Hey, Tom, are you there?
Whoops, sorry. I had it on mute.
No worries.
5 reasons why NVMe over TCP is cool. Did this presentation at Flash Memory Summit and got a pretty good response, so I thought, why not do it again? For those of you that don't know SolarFlare, we are the market leaders in the financial services industry for electronic trading and high-frequency trading. And the technology that got us there was low latency, low jitter, TCP and UDP. What we've done is we've developed a TCP and UDP stack that runs in user space. So this is not an offload like a TCP chimney or a TCP offload engine. This is an actual TCP UDP stack that we've hardened over the last 10 years. And we're now aiming that technology into this space along with the kernel solution, which all of us get to appreciate once the spec is ratified. So that's our place in the market. Let's go to the first slide. So Mike walked you guys through this. You've got Fiber Channel, you've got for the Ethernet, you've got Rocky, iWork, and very soon TCP. So TCP should be ratified. I'm expecting it before the end of this month. SolarFlare has been one of the contributing members to the working group in the NVM Express Consortium working group for TCP as a transport. So right now we're going through the final stages. I believe it'll be ratified before the end of the month. That will give everybody in the industry a TCP kernel plugin that can run on any Ethernet NIC. So everybody on this call, plus our other competitors, will all have the ability to run that. Where the big differentiators are going to come in is on the target side, where you've got lots of initiators banging on a target and you need higher performance. So this could be all flash arrays, a JBOF. It could even, in some cases, be in disaggregated storage. And I think that's where the real race will be, is who can offer the most performance and effective solution for the target side. As I mentioned before, one of the things that we excel in when it comes to technology is accelerating TCP and with our onload solution. Next slide, please. So here we're taking our kernel bypass technology, and what we did is we set up some Intel Optane storage devices. These are the super high performance storage devices from Intel, and we ran them with a Linux kernel NVMe OF over TCP. So you can see the gray box there. We ran it with SPDK, which is the cousin of DPDK. This is the user space solution that gives you direct access to the drives and to the SSDs. And that was run with a kernel as well, kernel driver on the networking side. But then we ran our kernel bypass acceleration technology along with SPDK. From the kernel solution all the way down to our onload and SPDK solution, there was a 54% lower latency using that technology. We provided this information at the Flash Memory Summit back in August. The actual SSD had about 10 microseconds of latency compared to 70-ish microseconds for a NAND SSD, and we added about 5 microseconds on top of that. So that's what our technology can do. This is standard TCP, so you could have anybody else's adapter card on the initiator side running the kernel plugin that's being ratified, and you would be interoperable with our solution on the target side. Next slide, please. Ease of deployment. So 98%, could be debatable, but we claim 98% of installed servers out there in the world today are connected with TCP. A very small percentage are connected with RDMA. Depending on whether it's iWarp or Rocky, there's a fairly small deployment. So TCP is everywhere. Next slide, please. Runs on legacy networks. So if you want to install any storage appliance running NVMe over TCP, you can leverage all of your existing switches. You can leverage all of your existing adapter cards, your endpoints. There's no need to do a forklift upgrade. Any of the other technologies, if you don't already have a Rocky or an iWarp network, if you don't already have a fiber channel network, you're going to have to do an upgrade to the network. So we take the new school technology and apply it in the old school infrastructure. Next slide, please. Ubiquity. It's a bit redundant, but TCP is everywhere. I don't think I need to beat that one into the ground. And the next slide. Sometimes I have discussions with customers and with supply chain partners that TCP's got congestion issues. A lot of folks will say Rocky addresses. And Rocky does address congestion issues because it's a predicted network. It doesn't send packets until you know you have some place to receive them. But TCP over the years has done a lot of ECMs that have addressed much of the congestion issues. So it's kind of an old tale that TCP is not an adequate infrastructure. If you have a poor performing network, yes, you're going to have problems. But a lot of the TCP issues that have existed in the past have been addressed in the TCP stack. And I believe one last slide, Mike. So the 5 reasons TCP is performant. Our kernel solution is within 3 to 4% of Rocky. Our kernel bypass solution is very high performance with the likes of an Optane SSD from Intel. Easy to deploy. Everybody knows TCP. Runs on legacy networks. It's everywhere. And the congestion issues of the old days of TCP, many of those have been addressed. That should be it, Mike.
All right, thanks, Tom. And last presenter, Praveen, go ahead and take it on. Hi, Praveen, are you there?
Oh, I'm sorry. I think I was on mute. Can you hear me now?
No problem. Yep, perfect.
All right. Hi, good morning, good afternoon, good evening, everybody. So I think as the title says, when you are trying to scale NVMe for shared accelerated storage, you need a real network. And there's some good news and there's some bad news. The good news is that customers have lots of transport choices to access NVMe natively over these shared disaggregated storage. And the bad news is that customers have lots of transport choices as they connect NVMe natively over shared disaggregated storage. Actually, you can build the slide out, and I'll just start talking to them. Awesome, thank you. So I think we've listed the different transport choices. NVMe is a block storage protocol that's been built from the ground up for flash, and it's displacing the other dominant block storage protocol, SCSI, which has been around for over 30 years, and that was built from the ground up for rotating media. Today, most of the SCSI block storage protocol runs on fiber channel. Over 90% of Fortune 1000 customers deploy fiber channel to run their tier 0, tier 1 workloads. About 80% of all flash arrays attached to fiber channel. 96% of the world's banks, airline, retail attached to fiber channel, and billions of transactions go through fiber channel every day. So fiber channel is a transport that was built from the ground up for storage and storage only, and it stands to benefit with NVMe over fabrics now that the FCNVMe standard has been ratified. Customers can seamlessly introduce FCNVMe workloads into their FCP SCSI workloads on their existing FC SANs. There's no need for rip and replace. The existing controllers from Marvell will support FCP as well as FCNVMe on the same controller. So we think if NVMe over Fabrics offers some good options, and Fiber Channel definitely can leverage this new standard. Besides FC, Marvell is also investing in other transports. So we do have capability to support Rocky V1, V2, as well as iWarp. Marvell does not have an InfiniBand support, so I'm not going to focus on that. And we have listed FCOE also here for more of a completeness sake, but we can transport FCOE natively, something similar to FCOE with FCNVMe over Ethernet. And last but not the least, most exciting, I think, from an Ethernet perspective is TCP, because it doesn't require any specialized configurations or any specialized network equipment for converged Ethernet, and really democratizes access to flash over large networks. So as a vendor, Marvell will support almost all of these transport choices minus InfiniBand, and we're really making it easy for the customer to make their choices based on what kinds of applications, what kind of latency tolerances that they have in their workloads. You can go to the next slide. So I think Tom has already talked about it, and so have the other two panelists, but NVMe over TCP is emerging as a potential for really scaling out storage, access to storage. We think workloads that have relied on iSCSI in the past will benefit from NVMe over Fabrics with NVMe over TCP. Again, no forklift offload. You should be able to leverage your existing Ethernet framework to take advantage of this protocol. You do have a choice of how much of an offload you want. If you deploy our adapters on the host and the target, then you can completely offload the TCP on the target, on the controller, or you could do what some people have done in the iSCSI space, or a lot of people have done, which is use a software iSCSI, or in this case, a software solution for NVMe TCP, but use an offloaded solution on the storage side for optimal latency. So and less load on the CPU for doing these operations. So I think the message here is really that we are enabling multiple transports, and we're really making it easy for our server and storage partners to bring solutions to market across different transport choices. Next slide, please. Oh, I'm sorry, I neglected to mention that we did win Best of Show at FMS for our NVMe over TCP solution that we collaborated with Toshiba on their Kumo scale. And to Tom's point, we were able to demonstrate near head-to-head performance of NVMe over TCP versus Rocky. Okay, you can go to the next slide. So again, I think just reinforcing the point that we have a broad portfolio of products that can help deliver the goodness of NVMe over a shared accelerated storage. We have different transports. We have 16 and 32 gig today, and soon 64 gig fiber channel. We have solutions with 10, 25, 40, 50, and 100. 100 should be here, it's a typo, for both RDMA and soon TCP transport. And from a flexibility perspective, we have both Rocky V1, V2, and iWarp, depending on your scale and complexity. Usually smaller deployments, maybe top of rack, Rocky is good. But if you have a larger, scale out, you want to look at iWarp as your transport of choice. Like I said, you can seamlessly introduce NVMe workloads into your FC or FC SANs, and then you can concurrently offload NVMe over fabrics along with existing ISO, iSCSI, and FCOE workloads. We have both host and target solutions today, so we are actively engaged with multiple OEMs, server and storage, to bring these products to market. And I think NVMe is enabling access to NVMe, or Fabrics is enabling access to NVMe, and we think FC NVMe is currently the most accepted storage transport for the storage networks.
All right, thank you very much. I guess you have one more slide.
Yeah, I think the message here is that it's really up to the customer, to our partner, how they want to deliver these solutions to market. We'll play in all of these transports, and we are investing across different technologies.
Perfect. All right, so let's go to the first panelist question. This question is, it will be started with Mellanox, then followed by Broadcom, SolarFlare, Marvell. Each will have a couple of minutes to answer. First question is, even though all of the major storage companies now support NVMe media in their all-flash arrays, NVMe over Fabric still kind of feels like it's in its infancy when it comes to all-flash arrays. What do you guys think it'll take for NVMe over Fabric to take off in the all-flash array space? And we'll start with John.
Thanks, Mike. I think a lot of the things that they need, that the industry needs, are already happening. So we have support from multiple vendors, including the vendors listed here, Broadcom, SolarFlare, Marvell, Mellanox. So that's definitely great support on the networking side. I think we need to see the major storage vendors move a little bit more in terms of supporting NVMe over Fabrics. I think we have recently seen some big announcements from vendors like NetApp, like IBM, who are supporting now NVMe over Fabrics. They're doing it with, some are doing it with fiber channels, some are doing it with InfiniBand, some are doing it with Rocky, some are doing it with more than one protocol. But I think we just need to see one or two more major vendors get on that bandwagon from the storage side. We have startups, we got NetApp, we got IBM, but we need to see, I think, like an HPE or Dell EMC also launch an NVMe over Fabric solution. And then I think we also it would be helpful, maybe not required, but helpful to see support for NVMe over Fabrics from Windows. Right now we have great support in Linux. VMware has announced support is coming, I think I don't know exactly when, but they've announced it's coming. So Windows support would help a bit, especially for the enterprise. I don't think you need it so much in the cloud for the cloud customers, and you definitely don't need it for the HPC customers. But in the enterprise, Windows support would be a big plus.
Perfect. Thanks, John. Let's go ahead to Laurent, if you want to take a shot at this question.
Yeah, so I think I'll echo some of the same things that John was saying. So what we're seeing, I think, is the tier one flash vendors migrating to NVMe now, and it's probably a prerequisite, for a large transition to NVMe over Fabrics, that those vendors, those tier one vendors, have an established NVMe product line. Some of the tier twos are probably ahead in that game, but from our perspective, the ramp will happen when those tier one product lines are established. And then the second thing is, as I mentioned in the introduction, the whole ecosystem had to come together, software, hardware, and it's only now, I think, that we're at a point where you can readily go and buy an ODM box that supports a Fabrics adapter. That happened in 2018. Yeah, so I think that's it for me. Yeah.
Perfect. Tom, what do you guys see from Solarforge's perspective?
I think two big things. So John mentioned one of them, which was the VMware and Windows support, and Windows being big, even VMware and Windows being big in the enterprise. The second one, shocking, I'm going to talk about is TCP. The customers that we've talked to, and this is cloud customers, telco customers, enterprise customers, are looking for the TCP solution primarily for simplicity, for ubiquity, for legacy infrastructure. And we're about to turn that corner. What's going to happen is the spec will get ratified, the kernel plugin will be available to everybody. So now it's a level playing field in that regard. And beyond that, the next step will be getting that kernel plugin pushed up into the Linux kernel. The third phase of that, and third and final phase, is going to be Linux distributions pulling from the kernel and having in-distribution solutions, or inbox or whatever you want to call it. And I think that's going to be what catapults this into the mainstream. And it's not that the other technologies aren't good, or that in fact some are even better, but it's the ubiquity of it. And I think that's going to really open it up. And people are looking for the performance. If you take iSCSI today and you map NVMe commands into SCSI and then push that over iSCSI, the performance is horrific. You're not anywhere close to direct attached storage. So people want the performance. They want to leverage the SSDs, but they also want the ubiquity. So I think those two things, the other OS vendors getting on board and TCP becoming ratified, pushed into the Linux kernel, and ultimately pushed into Linux distributions.
Thanks, Tom. And Praveen, what do you guys see at Marvell?
So actually, Mike, I would tend to agree more or less with what has been said by the prior panelists, more so with John. I think we really need a broad OSV adoption. We are engaged, with not just plugged into the Linux community, but also with VMware and Microsoft. So I think we need those solutions for the data center to really pick up momentum. And we're also plugged in with the tier one storage vendors, but we need some announcements in the short term, which are, in the offing. So it's just a matter of time, but yeah, it's just a little bit of more market momentum, both from a OSV perspective and from some large tier one storage vendors. The server OEMs are ready. It's just a matter of getting these products qualified and announced in the next 6 to 12 months. But for sure, we can see the end of the tunnel.
Perfect. Thank you. Yeah, go ahead.
This is Johnny. If I just add on to what Praveen said, I forgot to mention, and now that Praveen mentioned it, I think I would add that sort of agree with Praveen that even though some of those other tier one storage vendors may not have announced NVMe over Fabric solutions yet, almost all of them are working on them. And they're either working with Marvell or Broadcom or Mellanox or SolarFlare or some combination of vendors. So these announcements or these developments are in the works, and the announcements will be coming, but we just need to have more of them announced. And I also should have mentioned that Pure has announced, I think they're shipping NVMe Fabrics on their back end, as I think Laurent explained. You can have a front end or back end. So there are some announcements that happened, but I think the other tier one vendors are all working on it. We just need them to actually announce and ship the products. The ones who haven't already done so.
No, absolutely. Absolutely. So with that, let's go to the audience survey question number one. I'll launch the polling. All you have to do is go to polls in your control bar at the top of your screen and just go ahead and fill out the questions. I'll give everybody a couple minutes to take a shot at the first question here. And the question is, has your organization deployed or are you planning to deploy NVMe over Fabric-based storage in the near future? Or I'll give it another 30 seconds. All right. And by the way, the results will all be put in. I'll put these into the slide set when we publish the slide set. You'll all get a link to the slide set in about 2 days, and as well as a recording. Share the results here. You can see them now. With that, let's go ahead and jump to the second question on the panel. This will be started out by Broadcom, followed by SolarFlare, Marvell, and then Mellanox. And that question is, what do you think the primary applications will be that utilize NVMe over Fabric? When do you expect to see widespread deployment of these applications on NVMe over Fabric? And go ahead, Laurent, if you want to take the answer to this one.
Right. Yes. So basically, what we're seeing is those will be applications that require the scale, the performance, and the low latency that NVMe over Fabrics provides. And that could be in high performance backend, for example, or in a composable storage infrastructure. But just to go over a couple of examples of applications, what could be in-memory databases, which as they grow in scale, need hot caching, and Fabrics is a good technical solution for that. And those databases also need the ability, need a technology that supports disaggregation to enable multiple servers to access those databases. That's one example. But it could also be, key value store or data analytics, or any type of big data application. And in terms of timeline, as I think we discussed earlier, we're expecting to see a significant ramp in 2019, and even more so in 2020.
Perfect. Tom, what do you guys think on the SolarFlare side?
Certainly, backend storage applications, and if you look at disaggregated storage, web servers, application servers, software-defined appliances, and we're seeing a lot of applications where on the back end you've got in-memory database technology like Redis or Memcached accelerating traditional databases, combined with the NVMe OS storage. I think those are areas where we're seeing a lot of it. Also, hyperconverged infrastructure is a big candidate for this technology.
Thank you, Tom. Praveen, what are you guys seeing on the Marvell side as far as applications and timelines?
So I would agree with the prior comments. I'm just going to build on that. Since I'm holding the FC4, I'll say that OLTP, decision systems, data mining, decision mining. Those are some of the obvious candidates where they can benefit from lower latency, higher throughput, which is the promise of NVMe over fabrics. And in the longer term, I think maybe not so long term, but clearly AI ML workloads also will benefit tremendously with these configurations with NVMe over fabrics.
Thank you, Praveen. And John, I know you talked a little bit about this before. Do you want to add anything to the discussion?
Well, I think the other vendors have largely stolen my thunder because I would pretty much agree with everything they said in terms of the applications, things like disaggregation, back-end storage for storage arrays, also OLTP, AI and ML, as Praveen mentioned. Those, I agree with all of those. I would just add that we have already seen some deployments in high-performance computing where they're using NVMe over fabrics over typically InfiniBand. We've seen some small deployments in the cloud or a lot of testing, and I think leading up, which will lead up to big deployments in the cloud. And I was going to say again, AI and ML. Praveen already mentioned that, and a little bit too. I've seen some interest in maybe some deployments in high-frequency trading, which could be a NoSQL database or some other kind of database for doing really fast data analytics.
No, those all make sense. All right, guys, let's start the second poll. I'll go ahead and launch it. Give you a couple of minutes to answer the question. The second poll is, what are your primary concerns when considering deployment of NVMe over Fabric? And this is a check all that apply. All right, give another 10 seconds here. I'm going to go ahead and share the results so everyone can see them. All right, and with that, let's go to the third panel question. This will be started out by Tom at SolarFlare, followed by Marvell, Mellanox, and Broadcom. And that question is, how important will SmartNICs be for NVMe over Fabric, and where are they best used? Tom, go ahead.
All right. So on the SmartNIC side, if you look at, in general, where data centers are going, they're software-defined, scale-out infrastructure. I want to deploy once. I want to repurpose as many times as possible. So the SmartNICs give you that ultimate flexibility where you could add features such as dedupe, erasure coding, IPsec, or RAID, or not, right? So you could add it or not add it. You can use it or not use it. So that's one aspect of it. So you got a software-defined capability. The other one is offloading the CPU. So whether you're completely eliminating the CPU, like a Xeon processor, for example, or replacing it with a much smaller ARM, you could build a much more cost-effective storage appliance. In that, saving 100 watts, 200 watts, saving significant costs, and put that functionality that otherwise would have been used there into the SmartNIC. So those are the two areas I see: is the software-defined capability and the offloading of the traditional CPU and a software-defined storage appliance.
Perfect. Thanks, Tom. Praveen, what do you guys see on the Marvell side?
Mike, I almost feel like Tom stole my sheet. So I think I'm agreeing, wholeheartedly agree. I think, as JBORDs are evolving to JBOFs and JBOFs into EBOFs or FBOFs, you're looking for lower price points where, you really don't need a heavy-duty processor. A SmartNIC could be a great option to add and introduce some data services that you would otherwise have to deploy a big x86 processor for. And then, of course, with software-defined storage, you have the option of lower price points, and a SmartNIC could be a more approachable way of delivering some data services rather than putting down a big heavy processor. So I think I'm repeating the same sentiment, but yeah, I think that's how we see it.
Perfect. John, what do you guys see on the Mellanox side?
So I'd agree with what was already said, that definitely a storage controller. In certain cases, a SmartNIC can make a great storage controller where it is the CPU and the networking, and you don't need a separate CPU. So that certainly makes sense in some cases. And there are some systems out there, some from ODMs and contract manufacturers that are already showing this as sort of a NVMe over Fabrics JBOF that use different kinds of networking or SoC type solutions. But the other use case would be distributed software-defined storage or hyper-converged. We've got a couple of storage startups, people like E8 and Accelero, who are already working with our Bluefield SmartNIC to build, to offload some of either the networking or the storage tasks on the client, and that leaves more CPU free to run the virtual machines and the applications. So a software-defined or hyper-converged solution could certainly use the SmartNICs on the client side in a way to basically make a more efficient hyper-converged or distributed software-defined NVMe over Fabric solution.
Excellent. Laurent, what do you guys see at Broadcom?
Yeah, so I think my comments will be aligned with what was said previously. So, software-defined storage and CPU offload are the two main applications we see for SmartNIC. In the case of software-defined storage, we had a good example of that at the Flash Memory Summit, where we worked with E8, and they ran their agents on the Stingray SmartNIC. And the application, well, the interest for a solution like that is that not only you free up cores, valuable cores on the host CPU, but also it simplifies the maintenance of the software, because those two software can now evolve so that the SDS agent and whatever software runs on the host can have their own life cycle, their own maintenance cycles, and it also relieves some security concerns that come when you try to run the storage software on the same cores as you would the regular workload for that host. So that's one thing. And then as far as CPU offload in the back end, we're seeing that in the back end primarily for compression and encryption.
Excellent.
They're CPU intensive, and SmartNIC can do a lot to offload those features, those functions. And then just final comment. We are seeing SmartNIC being adopted, right? And as adoption grows and they become more ubiquitous, we think it's inevitable that more and more of the storage functionality will end up being ported to or integrated into the SmartNIC.
Perfect. That makes perfect sense.
Yeah.
All right, guys. Let's go ahead and we'll launch the last audience survey question. And this question is, what use cases do you see NVMe over Fabric utilized for in your organization over the next 12 months? We'll give you a couple of minutes to answer, and then we'll go into Q&A right after that. Going to give it another 15 seconds. All right, we'll go ahead and close the polling. I'll share the results. You guys should all be able to see this on your thing. And of course, as I said earlier, these will be posted in the slide set. So we'll go from there. On the Q&A side, we have one question so far, and that question is for Michael. I'm going to mess up your last name, so I'm not even going to try. But the question is, how much acceleration would NVMe over Fabric offer to the world of machine learning and deep learning applications? John, you want to start out? Let's kind of go through everybody in order then.
Mike, I apologize. I misunderstood the question. The question was just for Mike?
It's for Michael, and the question is, how much acceleration would NVMe over Fabric offer to the world of machine learning and deep learning applications?
Okay, I'm happy to offer my opinion. I thought you were going to have Mike answer that, but
No, we'll go through and ask everybody their opinion. So
Okay, sure.
go ahead and.
Yeah, sorry for the confusion there. So I think it depends on the workload, of course. It depends on how distributed the data is. But I would say in machine learning, you could see anywhere from a NVMe fabrics compared to using, iSCSI or regular fiber channel or regular, other regular protocols. You'd see anywhere from a 15% improvement to having to go 3 times faster. But again, it depends how many transactions how many times each transaction has to go to the storage, and what type of network you're comparing it to. So anywhere from 15% to 3 times better.
Perfect. Laurent, what do you guys believe on your side at Broadcom? Or what's your experience been?
Yeah, so one thing I would say there is that some of the solutions that are proposed for NVMe over fabrics and target adapters include quite a bit of processing, right? Those are typically SoCs. And those SoCs could be used to do a lot of pre-processing at the source, close to the data, so that you reduce the latency, you reduce the amount of data that has to be carried over the network. So it's not a quantified answer, but it's going to depend a lot on the application. But I would say structurally there's a lot of benefit you can get from the NVMe adapter SoCs that are on the market today.
Perfect. Tom, do you have an opinion on this from the software perspective?
Yeah, I actually would. I would take a step back and really pin down what you're comparing to. And here's what I mean by that. If you're running iSCSI on a spinning hard drive is measured in milliseconds, whereas an SSD is measured in tens of microseconds. So I'd start from the point of, is it iSCSI with SATA or SAS, or is it iSCSI with NVMe? If it's iSCSI with SATA or SAS, it's massive, it's huge. It's orders of magnitude. If it's iSCSI with NVMe drives, it's still going to be fairly significant. I think closer to the upper end of what John said in most cases. And as he pointed out, it matters how many times you're accessing the drives. But just look at the pure numbers. The standard NAND drive is about 70 microseconds. And if you look at the Rocky solution, or if you look at the TCP solution, you're looking at about 80 microseconds-ish over a network. And we actually did this. We mapped NVMe commands into SCSI, and then SCSI into iSCSI, and put it on an iSCSI HBA, and there was no comparison. It was a massive difference. And so some of the early all-flash arrays had that technology. They were using traditional either iSCSI or fiber channel with NVMe commands mapped into SCSI. You're going to get a massive performance boost when you go to native NVMe OF. I don't care which transport it is. You're going to get a massive performance boost, and then it's just a matter of how many times you're accessing the drives. It's going to tell you how much of a performance improvement you're going to see. I know that sounds like a generic answer, but it really does depend.
No, that's great. Praveen, what do you guys think?
So I think I would tend to agree with what has been already stated. I think it really depends on what you're referencing it against. Clearly, NVMe will deliver low latency, but I think given where you're coming from with the SAS, SATA, or iSCSI, like we've talked about, during the program, you will see a significant reduction in latency and hopefully an improvement in IOPS. I mean, AI, the learning or the training part is significantly IO and CPU intensive, because you're moving, data around the cluster, and if you can offload the CPU of, not worrying about the actual data movement, because the NIC can take care of that, then you see a better performance of your actual training workload, but you'll also see a faster data movement along the way.
Excellent. All right, we have a couple more questions. We'll try to get through these real quick. One, this is specifically for Preventable if the other panelists jump in afterwards. And that question is, how will NVMe over fiber channel impact the overall fiber channel fabric market?
Great question. Thank you for asking. I think probably that's one of the most exciting things right now. Like I said in my opening remarks, fiber channel was built for storage and storage only. 90% of Fortune 1000 customers are running fiber channel today. So what that means is that as AFAs are transitioning to NVMe native, maybe on the back end first and then on the front end thereafter, they will leverage FCNVMe. And the beauty is that, you know, it's no rip and replace. You have an existing FCP SAN. Now you introduce FCNVMe at your own pace. How aggressive, you know, you want to be with your workloads is up to you, but, you know, they'll coexist. And maybe workloads that are tier 0 plus, which, you know, require supreme low latency, maybe you prioritize those over others. But FC will, you know, you can leverage all the goodness of FC for FCNVMe, be it error recovery, be it discovery, be it all the other services, fabric services that Fiber Channel provides. So it's goodness. It's not going to cannibalize FC. It's only going to make FC more relevant.
Excellent. Laurent, I know obviously Broadcom also sells fiber channel products. What are your guys' view on this?
Yeah, well, so yeah, I'm not sure I have much to add here. We're in my product line, we're focused on Ethernet. Yeah, so yeah, no comment from me.
Okay. John or Tom, do you guys have anything you want to add to that discussion?
I would throw in there that if anything, NVMe OF gives fiber channel more legs. You know, it's an older technology. It's a very good technology, but I think it gives it a lot of legs because if fiber channel wasn't one of the transports for NVMe OF, I think there'd be a big problem there. So I see it that way. You know, if we get to the size of the pipe itself, you know, Ethernet's already at 100. Pretty soon it'll be at 400 gig. So that'll be a bit of competition, but I think I don't see it to the detriment. People who have invested in fiber channel infrastructure can leverage it. So that gives it longer legs. That's how I see it.
That makes sense. John, do you have any opinion on this one?
I mostly agree with what Tom said. FC NVMe means people who have fiber channel. It's another reason to keep using their fiber channel, maybe upgrade the speeds of their fiber channel SAN. But, you know, I don't think it's going to mean a lot of growth for the fiber channel customers, but I think it's a great use case for people who have fiber channel to keep using it and maybe upgrade their switches and adapters.
Perfect. And the last question we have, this one will be a hard one to answer, I suspect, because it's going to depend on the use case. So the question is, what is the delta IO latency or response time between what I assume means NVMe over TCP versus NVMe over fiber channel? Tom, you want to take a first shot at that one? And we'll go around.
Well, we haven't benchmarked that one. We haven't benchmarked it because kind of what I said a moment ago, people who have invested in fiber channel are going to continue using it. Not in all cases, but I think in most cases. A lot of our benchmarking has been against Rocky and iSCSI to date. And, you know, the iSCSI was just to show that the translation is a bad move. It takes all the performance out of the drives. And the Rocky, because it's the leading competitive technology. I know iWork is coming out, that Marvell's got a solution there. We haven't done that benchmarking yet. I couldn't give you a number. I'd be making it up. We've not benchmarked that.
Okay, John, do you guys have an opinion on this one?
We haven't done a direct comparison. I would say that traditionally, before you get to NVMe, I would normally say fiber channel has a lower latency than most protocols running over TCP, but a higher latency than most of the RDMA solutions, whether it's, Rocky, iWarp, or InfiniBand. However, NVMe over TCP, the one comparison I saw is there was a storage vendor that actually supported, they did a test with iSCSI over TCP, NVMe over TCP, and NVMe over Rocky, and they said that they got roughly something like 300 or 400 microseconds for total, this is media plus network plus software. So 300 or 400 microseconds for iSCSI over TCP, I think 200 microseconds or 180 microseconds for NVMe over TCP, and like 100 microseconds for NVMe over Rocky, over fabrics on Rocky. They didn't test fiber channel directly in that, so there's no comparison, but I think regular TCP fiber channel have lower latency. NVMe on TCP, hard to say. We haven't tested, so I think we'll have to find out.
I think that makes sense. Praveen, do you guys have an opinion on this?
Sure. So I think we need to take a little bit of a step back. Like John said, I think the latencies are in the neighborhood, and as Tom said, if you're really looking at the switching level, you're down to nanoseconds, hundreds of nanoseconds. If you're looking at just the transport itself, you're in microseconds. But if you look at the overall end-to-end latency, right, if you're including all the data services, all of the other good things that happen behind, LUNs, you're looking at hundreds of microseconds. So I don't know if, just comparing one number against the other is how a customer is going to choose, because if you're looking at a 300 microsecond end-to-end latency, if you have 2 or 3 microsecond improvement, that's really not going to move the needle for you. What's probably going to matter more is what are your use cases, what are your existing investments, what are your, how mission critical are these workloads, and that'll probably define and drive your choice of transport.
Perfect. See, I think that's pretty much it, guys. Well, thank you again. As I said, the recording for this will be posted on Thursday along with the slide set. Thank you, everybody. Have a good day, and don't forget to vote.